Happy Tuesday, Precal. Hope everybody had an amazing 3-day weekend. I sure know I will try to, seeing as I'm up here on a Saturday. My weekend has yet to start, but I will hopefully have an amazing weekend myself. Getting the room decorated for open house is happening tonight. Hopefully all your parents can be there. Yeah. So let's get busy. Today we're going to be talking about even and odd functions. Even and odd functions. All right. So a couple of things here. What makes a function even or odd? Your y-axis symmetry, origin symmetry, and x-axis symmetry are going to play a pretty big part in that. So let's talk about what each of these really are going to mean here. If x comma y is on the graph, to have a y-axis symmetry, that means that negative x, y is on the graph. Basically saying if you cut your y-axis down the middle there, what's on the right is going to be the same as what's on the left. That's called y-axis symmetry. So for example, this point right here, we got 2 comma 0 is on the graph. That means that negative 2 comma 0 is also on the graph, and it is, right? You can do that with any of them. 1 negative 3 right here, negative 1 negative 3, 3 comma 5, negative 3 5, right? A function whose graph has a y-axis symmetry is called an even function. Y-axis symmetry means it has an even function, all right? Then you got your origin symmetry. You know from your origins that if xy is on the graph, that negative x and negative y have got to be on there, right? Negative x and negative y. So for example here, 1 comma 1 is on here, right? 1 comma 1. So you know that negative 1 comma negative 1 is on here. 8 comma 2 is on here, so negative 8 negative 2 is on here, right? And a function whose graph has an origin symmetry is known as an odd function, right? So a couple of things about your x-axis symmetry just pretty quickly. X-axis symmetry is when you have xy, you know that x negative y is going to be on there. In other words, you have 1 comma 1 to have an x-axis symmetry, meaning it's symmetrical across this axis right here. It's like a mirror looking down into a lake or something like that. You know that it's got to be symmetrical across the x-axis if x and negative y are on there. So like here we've got 9 comma 3, right? You've got 9 comma 3. You know that 9 comma negative 3 has also got to be on there, which it is. Now if you have x-axis symmetry, that means that it is not a function. It means that it's not a function. Okay? Now a quick little bit of advice for origin symmetry. Here's an easy way to tell if something has origin symmetry. If you take your pencil and you put it down on the origin, 0, 0, and you flip this thing upside down, if you get what you started with before you flipped, it's an origin symmetry. You see how this goes down on the left and up on the right? Flip it back around, and it's down on the left and up on the right. So put your pencil on the origin, flip it around, and it'll tell you if it has an origin symmetry. All right? So just a few little definition here. An even function is f of x is equal to f of negative x. If x and negative x are the same, then you've got an even function. It's basically what the y-axis symmetry is saying. If x is positive and x is negative and it's the same points just across the y-axis, it's an even function. Odd functions are if the negative x and the negative y's are the same. If you put a negative in front of x and a negative in front of y and you get the same thing, then it's an odd function. All right. So we're going to complete tables to determine if f of x is even, odd, or neither. Now if you were to plug a -3 into x squared, you would get 9. -2 squared is going to give you 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So we have negative x values for -3 gives you +9. +3 gives you +9. Your negative x values give you the same y values. We would call that, for this one, even. Alright, let's keep going though, and let's see what happens. We can go ahead and write that down here. Even, it's talking about f of x. Alright, f of negative x means we put a negative x in here. So if I put a negative x in here, if I get the same thing as I did right here, it's going to be an even function, right? If I put the same thing in here, or if I get the same answers as I do here, it's going to be an even function. So let's see what happens here. Negative x means if I put a -3 in here, it's going to look like this. It'll be -3. Because x is -3, and I've got another negative outside of it. Well, what's -3? +3, and +3 squared is 9. Fantastic. -2, same thing. -2 squared is 4. -1 squared is going to be 1. -0 squared is 0. Now when you get down here, it's going to look like this. -1 squared. Well, -1 squared is still +1. It's a negative times a negative. Here, -2 squared is 4. -3 squared is 9. So you plug in a -3, you get 9 on both of these. You plug in a -2, you get 4. Plug in a -1, you get 1. All of these points are the same. What this is saying is if you take f of x and you take f of -x and they give you the same numbers, it's even. So right off the bat, I can tell you that f of x is even because f of x, these guys on the left, I probably wrote this a little early, but these guys on the left are equal to these guys on the right, f of -x. Now just to make sure, let's check and see if it's odd. Odd function, remember, if it's odd, that means that f of -x, these guys, will equal these guys. Alright, so now the negative is outside of this guy. Now if you follow your order of operations, parentheses, exponents, then multiplication, so your exponent comes first. This is -3 squared, which is 9, times -1, -9. Negative, parentheses, -2 squared. -2 squared is 4 with a negative in front. So this will be -1 squared. That's 1 with a negative out front. -0 squared is going to be 0. -1 squared is going to be -1. -2 squared is going to be -2. -3 squared, oh, not 2, goodness, 4 is -9. Are these numbers the same as these numbers? No. So that tells me right off the bat that it is going to be, since these are the same, it's going to be even. All right. If you want to rewind that one more time, feel free to. Okay, so next we have to determine, excuse me, bump this down a little bit, algebraically if each is an even, odd, or neither function. So first I've got f of x, that's given to me. So what I'm going to do is figure out what f of -x is. And then after that, I'm going to figure out what negative f of x is, and I'm going to see which ones match which ones. Even, odd, or neither. Remember, if it's even, these guys will match. If it's odd, these guys will match. If none of them match, it's neither. So if I put a negative x like this, negative x cubed is negative x times negative x times negative x. That's 3 negatives, so that's going to leave you with a negative x cubed minus 4. Down here, I've got negative x cubed minus 4. Distribute your negative and you have negative x cubed plus 4. So the first thing you're going to ask, for even, these guys are going to be the same. Are they the same? No. This is a negative x cubed here. For odd, these guys are going to be the same. Are these the same? No, because this is a positive 4 here. So here's what I would write. F of x does not equal f of negative x, so it's not even. F of negative x does not equal negative f of x, so it's not odd. It's neither. Okay, if that messes you up, keep going. We'll try some others here. All right, f of x is equal to the absolute value of x. All right, the absolute value of x is going to look something like. Sorry, let me organize this paper. This f of negative x. Throw a negative inside there with your absolute value. What do you get? You get the absolute value of x, because that's what the absolute value does. It gets rid of negatives. What if you put a negative on the outside? Well, that's just negative absolute value of x. That doesn't match with what this guy has here. So I'm going to say, since f of x is equal to f of negative x, this guy is equal to this guy, that this whole equation is even. Last one here. F of negative x, you put a negative inside, a negative x inside of where every x is at. Plus, so I'm going to open up a set of parentheses. Everywhere I had an x, throw a negative x inside of there. So you have negative x cubed, which is going to be negative x cubed, and another negative outside. So that's going to change that to a positive x cubed minus x. Now if you put a negative outside of everything, that's going to change this to a positive x cubed and a negative x. Notice how these two things are the same? These two are the same. That means it's an odd function. Alright, let's go to the back. One more, just a few more things here. There we go. It says complete each graph for the given type of symmetry. Tell whether the resulting graph is a function and if it's even, odd, or neither. Alright, so an x-axis symmetry. X-axis symmetry means these points are reflected across the x-axis. So I want you to reflect all of these points across. Instead of 4, 1, it's 4, negative 1. Instead of 1, 2, it's 1, negative 2. Instead of negative 4, 3, it's negative 4, negative 3. On and on and on. Is it a function? No. Even, odd, or neither? It's an x-axis symmetry, so neither. Alright, y-axis. Reflect these points across the y-axis. So that'll go here. 6, negative 2 will be negative 6, negative 2. 8, negative 2, negative 8, negative 2, and 10, 3 will be negative 10, positive 3. Notice it has a y-axis reflection here, meaning the right side